Okay, so here we're going to start looking at 25 samples of size 4. Now I've said that I gave ChatGPT a brief to generate the car prices for me, and part of that brief was I wanted more of the car prices to be towards the lower end of the price range. So what we should see is positive skewed data. So let's see if we do see that. And let's go ahead and run this. And we don't really see it when we're just taking 25 means. And of course, with just 25 samples, we are going to see some variability. That looks quite different, doesn't it? And if we do that again, it'll probably look different again. So we don't actually see that. What I'm going to do is have a lot more samples. So I've adjusted this so we get 10,000 samples, but it's still of size 4. Remember, that's the size that really makes this distribution. So with just n equals 4, we should expect to see this positive skew to the data. Let's see what happens. So saying 25 sample means at the top of the histogram, I didn't bother about changing that, but I can see this data is positively skewed. And if I generate a second one here, again, it's a bit different to the previous one, but we do have a positive skew to it. And we should see that smooth out as we move upwards in terms of n, which is the sample size. So I've changed the sample size to 9. We're still going to do 10,000 of them because 25 just has too much variation to really see anything. And still a bit of a positive skew, but I'd say a bit less. Let's just generate a second one and see if it compares. Again, a little bit of a positive skew, but definitely I would say less than when n was equal to 4. Let's go to n equals 16 and see what we get there. So let's generate this with n equal to 16. See what this looks like. Again, it's still 10,000, and I think that that has smoothed out. Let's have a look again. And I would say that that also a very, very slight positive skew to it. And let's just go up and let's try the magic n of 30. When I say the magic n, of course, I'm talking about the figure that you're expected to quote in exams. The more skewed the distribution, the larger the sample size really has to be to smooth out that skewness. Let's have a look and see what happens. We've got 10,000 of these, and I would say that that has smoothed out that positive skew. This one actually looks a little on the negative side, doesn't it? Let's generate another one because there's always going to be variation in the samples. And I would say that that positive skewness pretty much has gone. It's looking a bit more normal, isn't it? And being that there is only 72 cars, it's actually pretty difficult to go for very much larger samples. Let's do half the cars. Let's go for 36. We probably won't see a lot of difference between 30 and 36 because, as we know, that's not a very big difference. So let's just do that. 10,000 of those. And yeah, it's looking definitely a bit more normal, but certainly smoothed out that positive skew. And that's what happens, and that's why the n equals 30 figure is one that you quote in exams, because when a distribution is skew, taking samples of 30 will smooth out some of whatever skewness you've got and make it more symmetrical, more normalized. And of course, the bigger the samples you can take, the better. N equals 30 is just a figure that you're expected to quote in exams.